Alright everyone, welcome back to the Syntax Byte channel. Ryan again, and in this video we are going to spice up our game a little bit by adding some motion. We're going to get these clouds moving in this video, as well as we're going to add our Flappy Bird and get the jumping motion going as well. So to do this, we're going to use Tween.js. That is another aspect of the Create.js suite of libraries. To get started, what we're going to do is, normally in a game, if you've done any sort of game programming before, you know that there's kind of usually an update function that basically runs on a loop. You might run it at a particular interval, try and hit 30 or 60 FPS, or you might just run it as fast as possible to update the game. What we've done thus far is, after we've added anything or made any changes to the display, we've called the stage update function once so that it will update the display, but we actually want to update that regularly. So we can remove both of those calls and actually add in the timer or the ticker from Create.js's TweenJS and use that to update the stage instead. So what we're going to do is right under here where we add the background. You know what? In fact, we can even do it right when we create the stage. How about? We're going to create the ticker. So we'll do create.js.ticker.timing mode is going to be create.js.ticker.raf synced. And what this is going to do is it's going to go basically target a certain frame rate. So now we need to set that frame rate. If you just put RAF here, it will go as fast as possible with basically just ignoring the frame rate variable. But we want to target a certain frame rate. We're going to target 60 FPS. One thing you have to keep in mind, we're going to be using TweenJS for basically all of the motion in this game, but if you're creating a more complex game where you're going to add an update function of your own and do some sort of movements where you're updating something by a certain value each frame, if you're using the synced version, it's okay to do that. If you're using just RAF, trying to go kind of as fast as the computer can keep up, basically at that point you'll need to have some sort of a function for delta time to see how much time has passed since the last update and update based on it. Otherwise your game might play at different speeds depending on the power of the computer. We don't have to worry as much about that because we're just using TweenJS to do most of our updating here, so it's not really as much of a concern. So then we want to add something to respond to the tick. So every time it ticks, it will send out an event tick. And what we basically want to do is we want to tell our stage to update. Because everything works so nicely with these libraries, we can actually just pass it the stage and it knows what to do from there. We don't have to create a function or anything separately. So on tick, pass it stage, stage will respond to that event. So we're going to target a frame rate of 60, and that should get things updating. So now that we have this in here, we actually shouldn't have to place a stage.update call basically anywhere else in our code. It will be called repeatedly automatically for us by the ticker. So we shouldn't notice any changes if we go ahead and refresh. It should all kind of work. There we go. So it's still working as we thought, but it's now being updated by the ticker instead of those stage update functions. So now that we have the ticker in place and we're constantly updating it, we can actually update some of the values, like the X and Y values of our clouds, and they will actually move rather than just stay stationary like they are now. So you, of course, don't have to add motion to the clouds. They could just be a static background item, but I think it looks a lot cooler when we add motion, and it's a great way to get familiar with the TweenJS API. So what I'm going to do before I add it to the stage there is actually add a tween. What is a tween? Well, a tween is basically an animation. Okay, it specifies to transition values between one value to the next, filling in the gaps using a certain easing. Okay, so you could just do it linearly. We'll see that later with the pipes going across the screen. They just move across in a linear fashion. our clouds, we actually kind of want them to speed up and then slow down as they're moving. So they're not going exactly the same pace every time. I also want to add something in here to make them go in opposite directions of each other. So we'll add that in there. So the first thing we're going to do is add a variable that's going to determine which directions our clouds are going. I'm going to call it direction multiplier. And that is going to be equal to I modulus 2 equals 0. So if it's even, we're going to go -1, else we're going to go forward. So that's how that sort of works. So if this index is even, we're going to go backward. If it's not, we're going to go forward. Then we need to keep track of what the original x position of the clouds is. So we're going to move the clouds side to side. That's moving along the x-axis. We need to keep track of where they originally were, so we know to end them up back there. Of course, each cloud is different, so we want to sort of cache that here. So I'm going to say original x equals clouds I dot x. And now we can go ahead and add our tween. So we'll do Create.js dot tween dot get clouds I, and then we want to loop it because our clouds are going to stay in motion basically the entire game. So we're going to say go ahead and loop it. Then we do .to, and this is where we specify the properties we want to change and the order that we want to change them. So we want to change the x value, and we want to do clouds I dot x. So where we are right now, and then we want to do minus 200 times the direction multiplier. Okay, so we're going to adjust it by 200 pixels times our direction multiplier. Of course, we're subtracting it, so it's actually going to, like if it's -1, it's actually going to end up being a positive. But it doesn't really matter. We just want our clouds to go in opposite directions. So with that being done, now we need to specify how long do we want it to take to do that. I'm going to give it 3 seconds, but you can play around and use what looks best for you. And then we specify our easing. So if we don't specify easing, it will just go linearly, but we actually want it to start slow, get fast, and then slow down again before the animation ends. So you can do that with create.js.ease.getPow in out. And I'll do 2. So if you use a higher number here, it should be a little bit more aggressive in the easing, like the effect of the slowing up and speeding up and slowing down should be a little bit greater. I'm just going to use 2 there, so it's not a super huge effect. Finally, once we've adjusted it, we need to set it back to its original x. So we're going to say x equals original x. And as I'm writing this, I'm doubting whether we even need this variable. We could probably just do it like that, but that's okay. We'll leave it as it is. That's how I have it in my notes. I know it works. We're also going to take 3 seconds to go back, and we're going to use the same easing. So ease get pow in out to. So that is going to add that tweening to our clouds, and of course it's going to loop, so it's going to go back and forth. So now when we refresh, we should have clouds sort of animating back and forth. So let's see if we do. And look at that. We do. So we can see that the clouds are kind of going back and forth, and they'll continue to do that throughout the game. You can see as they start going, they get faster, and then they get slower again. And it looks pretty awesome. Pretty satisfied with this effect. They do go a little bit off the screen. That's a little bit intentional. I like that effect. I think it looks cool. But you could, of course, play around with your X values and how much you're adjusting things by if you didn't want yours to go off the screen. So this is a pretty cool effect, and our game is officially in motion. So now what I want to do, that's basically it for creating the environment. We have the background, we have the clouds. Everything looks really good. What I want to do now is I want to go ahead and add our Flappy Bird onto the screen. So we've already loaded in the Flappy Bird graphic. I'm going to create another function called createFlappy. Now, of course, you could all have these in the same function, but I'm just trying to keep things separate and clean as I can here, without using more advanced features like, you know, classes. But yeah, just trying to keep things neat. So I'm putting everything in separate functions at least. So we're going to create Flappy. And one thing with our Flappy is we want to be able to actually access it elsewhere. So up here where we kind of have our list of globals, I'm going to go ahead and add Flappy to that list. The clouds, I don't really need to access them from elsewhere. Once they're on the canvas, yeah, I don't really need to get them. But I do want to go ahead and access my Flappy. So I'll put that as a global. So to create our Flappy, it's going to be another bitmap just like the clouds. So Flappy equals new create.js.bitmap. And we're going to do a loader.getResult. We called it Flappy. So now our Flappy, we want it to be basically exactly in the middle of the screen. What's also going to make this tricky is that our Flappy, we want to rotate it a little bit. You know, have that effect going as it goes up or as it goes down. So in order to rotate our Flappy, it's going to rotate around a point called, I believe it's called the registration point. And in order for it to, you know, spin properly, I guess you would say, as you would expect, things usually spin around their middle. So we want to set that to be the middle. That's also going to affect how our X and Y coordinates sort of work, because that's going to set the basis rather than as the top left corner like we experience with our clouds or with our background. That's actually going to set the X and Y coordinate to mean the middle of the Flappy should be placed at that X and Y. So if you're trying to center something in the screen, it's actually a little bit easier to do it when it's this way. And this is necessary for the rotation. So normally I wouldn't set these variables, but it's necessary for the rotation. And we'll get to that in a moment. So I'm going to set regx is equal to Flappy.image.width divided by 2. So in the middle of Flappy, Flappy.reg_y equals Flappy.image.height divided by 2. So in the middle height-wise. And then I want to do Flappy.x is equal to stage.canvas.width divided by 2. And Flappy.y is equal to stage.canvas.height divided by 2. So this is getting the exact middle point of the screen, which only really works to center Flappy because we set these other variables here. Then we can go ahead and do a stage.addChild Flappy. And Flappy should be on the screen now, so let's go ahead and check it out. And Flappy is on the screen, ready to go, but of course we can't click and actually jump with Flappy. Flappy's stationary at the moment, so we want to go ahead and use the same techniques that we did to get the clouds moving to actually get Flappy going. Now I will note that I think this is a really elegant solution that I came up with for this game, but for most games you're probably going to have a separate update function and, you know, do some sort of a physics simulation or something like that. I wouldn't necessarily always suggest using Tween.js to create player movement, but in my case I think it's a really elegant solution that I came up with, and it just really shows the power of Tween.js, but maybe not quite what it was intended for. So I will show you later in the video series how to add sort of a more traditional update function and update any values or do any sort of checks that you would normally do basically once a frame in a game. But in our case, we don't actually need to worry about, you know, adding some sort of physics or gravity. We can kind of use Tween.js in a way to actually make this work. So to start with, we need to actually respond when the user clicks the screen, so we know that that's when Flappy needs to jump. And I'm going to let my Flappy start just stationary, and this is kind of the starting screen for the game, and once the user first clicks, they'll be kind of in the game. So what I want to do is I want to go up to our handle complete, and I want to add a listener for when the user clicks on the screen. So in handle complete, I want to do stage.on. This is equivalent to add event listener, but I just usually use this one for stage for some reason. Stage mouse down. We want to call a function called jump Flappy, and that's going to make Flappy jump. So under create Flappy, I can create my function jump Flappy. And in here, we need to make Flappy jump. So how do we do that? Well, again, I'm going to use another tween. So I'm going to do a create.js.tween.getFlappy. we're going to pass override equals true. So last time we looped it, we're not going to loop this. We don't want Flappy to continue jumping if someone just clicks once. We only want him to jump once when you click. However, someone might click multiple times before he's finished jumping, because if he's actually finished jumping, that's going to mean he's all the way at the bottom of the screen and hit the ground. If someone clicks the screen while he's not all the way at the bottom of the screen and hits the ground, we want to jump him, and we want to cancel the tween that we had before because we don't want him to go to the ground anymore, because we're going to set up a new tween that tells him to get to the ground. So hopefully you'll kind of see how this works, but we're going to cancel any existing tweens on Flappy, only have one at a time. So this will keep getting canceled until it doesn't and Flappy hits the ground at the end of the game, or he may never hit the ground. So we're going to do 2. We're going to say y is going to be flappy.y minus 60. Now y increases as you go to the bottom of the screen, because remember, it's the top left corner, and as we go down from the top left corner, y is going to increase because that 0 is at the top of the screen and that 480 is going to be at the bottom of the screen. So that's how we do that. So we're actually going to subtract 60. You can play around with this. 60 is going to determine how high Flappy jumps, along with the timing. So you could play around with this and the timing to see what feels right for you. I've had to play with them and I like 60. The other thing that we're going to change Flappy's rotation. So when he's going up, when he gets to the absolute, he's at his highest, we want to rotate him up to minus 10. So he's going to be kind of on a tilt, putting his beak up. And, as he goes up, he's going to put his beak up. And then as he goes down, he's going to put his beak down. So that's up. We're going to put him 60 pixels above where he was and rotate him minus 10, so he's got his beak up. We're going to do that in half a second, 500 milliseconds, and we are going to ease him. We're going to ease him a little bit because we want him to start really fast with that jump up and then kind of peter out a little bit. He kind of loses strength as he's getting up there and gravity starts to take hold. And then same thing, when the gravity starts to get hold, it's slow. He slowly starts descending, and as he continues to descend, he's getting faster and faster and faster. So in order to have him start fast, he's got a lot of momentum when he first kind of flaps his wings and jumps, but he sort of loses that momentum. We want to do ease.getPowOut. So whereas before we did get pow in and out, start slow, go fast, end slow, we want to start fast, end slow. We don't want to start slow, go fast, end slow. We want to start fast, end slow. So that's why we only do get pow out as opposed to get pow in out like we did before. So now he's going to jump. So now he's jumped, but we also need to bring him back to Earth, unfortunately for Flappy. So when that ends, and again, this is assuming that the player doesn't click again and restart this function, putting him another 60 pixels above where he was. We're continuing. 500 milliseconds is over. Flappy needs to start descending to the ground. What do we need him to do? We need to take the Y all the way to the bottom of the screen, basically. So we're going to say stage.canvas.height plus flappy.image.width divided by 2. And so if his 0, 0 is in the top left corner, we could just do stage.canvas.height. That would get him all the way off the screen. But because it's not, we actually need to add that little extra bit that's kind of at the top from above the middle of him. And so that's why we do the image width 2 calculation. We're also going to rotate him, so we're going to set him a rotation of 30. You can get more aggressive here. I actually prefer it to be a little bit more aggressive, but with our collision detection, we're not actually going to rotate the collision rectangle, so you'll see that later. If you have better collision detection, I would actually recommend rotating him more here, but we'll talk about that later. For now, this effect is, strong enough to be cool, subtle enough to not really mess with our collision detection too much. We want him to take a lot longer to fall than it took him to rise. He's generally going to be going a lot further. So in this case, we're going to allow it to take him about 1.5 seconds. and Create.js.ease.getPow in. So as opposed to our getPow out where it was start fast, go slow. Now we want to go start slow, go fast. As he's descending, we want him to get faster. So that's why we use getPow in. His speed is exponentially increasing by a factor of 2 as he hits the ground. You could even raise this to make the effect a little bit more pronounced. So he'd be hitting the ground really, really fast, but when he just starts, he's like almost like floating on the air. He's just kind of floating there, but then he hits the ground really, really fast. So you can play around with these numbers too and see how that changes the movement of our Flappy. When that's done, we want to call a function. Now, this function will only get called if this tween isn't overridden by another tween. So if he's falling and then the user clicks the screen, we'll put him back up 60 again and then start him falling again. And this function will never be called because the last tween didn't finish. That's what this override true means. It means cancel the previous tween. If it ever finishes, we know that Flappy has hit the ground. That's what we asked him to do in the second tween. We asked it to, hey, take Flappy all the way to the ground. So in that case, we can simply call game over if Flappy falls off the screen or if he hits a pipe. Those are the two ways you can lose this game. But if he falls off the screen, it's game over for Flappy. And so we'll create a function, game over. And right now, I'm just going to simply log game over, but you can, we'll add on later. You can do an alert to game over. Simply log that occurred. So now we can go ahead and refresh the screen. I'm going to go ahead and open my log so we can see if the game over is triggered. He's here, he's not doing anything. We click the screen and he starts going up. And so you can see I can keep clicking him. He goes up, he goes up, he goes up. And as he goes down, he starts falling faster and faster. Yeah. So that's that. So he goes down, like if we take him all the way up to the top of the screen, we can even go way above the screen. Starts falling. He's got this little rotation about him. And it's just like it works just like we would expect Flappy to sort of work. So it's pretty cool. And if we let him fall all the way to the ground, boom, he's off the screen and game over gets called. So that is how we get Flappy on the move. Of course, it doesn't actually, he doesn't continue to fall after he hits the ground, so we can spring him back up again, but in the future we'll actually end the game, and that won't be possible. But for now, this is pretty cool movement with Flappy. He waits there until we do the first click to start the game, so that's good. And so now what we really need is some pipes. But we're going to cover that in the next video. We'll get the pipes going, and we'll also get some collision detection going and really put some polish on this Flappy Bird game. But until then, guys, I will see you in the next video. Again, it's been Ryan on the Syntax Byte. If this video is helpful, like, comment, and subscribe. If you're having issues, throw me a comment below. Of course, the source code is in the description below with my written tutorial. So if you just prefer to reference it there, if you missed something, definitely go ahead and do that. Anyway, guys, I will catch you in the next video. We're going to implement some pipes.